Hello students. In this particular lecture, I am going to discuss about a key concept in motion, that is the net force. Most of my students during my teaching years, I found that so many students confused with the concept of force and concept of the net force. They treat the individual force as a net force. That is really a confusing thing, and that's why it is important to clarify that concept of the force and concept of the net force is total different thing. So let me start by asking a question. Currently, you know I am here standing still. Does that mean no force is acting on me? What do you think? In other words, if an object is sitting still, does that mean no force is acting on it? What do you think? You think, as majority of people think, you may think that no force is acting because object is standing still, right? But that's not true. We often assume that if something is not moving, then there is no force on it. But actually, many forces might be acting and they can cancel each other. Okay? This is the misconception actually. Okay? You take a book and put in a table. That book is resting on a table. What is happening there is the earth pulls that book downward with the force of gravity. The table pushes upward with the same amount of force but opposite direction. That we call the normal force. And these two forces actually balance out. If the gravity force is 2 Newton, the normal force is also 2 Newton, but one is plus, another is minus, they cancel out, it becomes 0. That's why the book stays still. Okay, an object at rest or moving at constant velocity can still have forces acting on it as long as the net force is 0. So let me define what is net force. Okay, what is net force? What is net force? So if an object is there, that object experiences the different force from the different other object. You cannot apply the force by yourself. You should apply the force to other object. Okay? So there are many forces acting on an object, and we have to take into account all of the forces acting on that object. So the net force is the overall forces acting on an object when all individual forces are combined vectorically, because force is a vector quantity, right? Force is a vector quantity. So the vector sum of all of the forces acting on an object is called the net force. So net force we call that is F net, that is vector notation, force, net force, or we can use the terminology, the total sum of all the forces acting on an object is the net force. So if net force is 0, we can say that F net then the object can be at rest or moving with the constant velocity. Okay, net force is 0, but no individual force 0 there. So most of people think that if car is parking on a garage, net force, so the force acting on a car is 0. No, forces are still acting on that, but they are cancel out and makes the net force 0. If net force is not 0, then object will accelerate. It will change the speed and it will change the direction. That's how we feel the force. You are driving a car in a straight road with the same velocity, you are not changing in direction, I don't think you will feel any kind of force. But net force is zero still. But when you turn, when you change the speed, then the passenger will feel the force. That is the net force we feel. Okay. So two important things we will discuss about Newton's first law and second law. Where net force is zero, object will be at rest or object will be in the motion with constant velocity. But if there is a net force, certain value of net force, then object will start to accelerate. Then the second law, we'll discuss about that. So let's take some everyday examples of different situation and the force acting in those situations. Okay, book on a table. What are the forces acting on that? Can you tell me? You have a table, you have a book here. So what are the forces acting here? You have a gravity and you have a normal force from the table. Gravity downward, normal force up, but they are equal and opposite, net force becomes zero. So if net force becomes zero, then the object remains stand still or remain in the same velocity if it already has a velocity. Ball falling, so there is only the gravity acting, so there is no net zero. There is a certain value of the net force. Okay, so falling apple has the acceleration. Person pushes a box. In this case, you have a friction force, you have a push force. Push is greater than the friction, that's why object is start to move. So net force certain value, so it is speeding up. So this situation you need to be familiar. So concept of net force is very important thing. So how do you know there is a net force or not? You have to begin with the free body diagram. Okay, let me discuss about the free body diagram here. We call it is FBD. So constructing the free body diagram, FBD is very important task to analyze the motion, to find the force. So the free body diagram is a simple sketch that shows all the forces acting on a single object. Okay, we'll take one example. For example, a box is being pulled. Let me take a situation. A box is, let me write down the situation. A box is pulling or being pulled, we can say that is being pulled, is being pulled. A box is being pulled by a rope, right, to the right, with a rope, sliding on the floor. This is the situation. So you have many things involved here. Okay, I'm talking about free body diagram, very important topics we are going to discuss here. Okay, so here you have different objects. You have a box, you have a rope, and somebody pulling, so another person, three, and you have a ground. There are many objects there. But what is object of interest in this situation? We are analyzing the motion of a box. That's why box is an object of interest. So you have to just take one object at one time. Okay? You cannot visualize all objects force at one time. You have to do once at a time. Okay? So first of all, what you have to do, you have to first identify the object of interest. That means you have to isolate that object of interest with other object. Okay, and that object is the object of interest. Here the box is object of interest. Box is the object of interest. OI means object of interest. Then you have to replace that object of interest by a dot. That makes things easier. Suppose dot is a box. Suppose box is denoted by B. Let's say that. Okay. Then what are the forces acting on the box? There are many forces here involving in all of the subject, but you have to only take the forces acting on a box. What are the forces acting on a box? We have to find out here. Okay, so what are the forces acting here? One is the weight of the box. Okay, weight of the box is downward. Always weight force acting downward. Then box is on the ground. Ground provides the normal force upward. That's why it is not going deep, not making any hole on the ground, remain on the ground. So weight is balanced by the normal force exerted by the ground that acts on the box. All the forces acting on the box, that is the normal force denoted by N. You can see, these different forces. Let me write down the notation. What we're going to use here? Normal force is N. So see this table. Then somebody is pulling. Suppose somebody is pulling a step with a certain rope. That is acting forward, but at the same time, something is doing against it. That is the friction force F. Friction force by ground acting on the box. All forces acting on the box here. So the rule to construct the free body diagram is, first of all, you need to identify object images. That means you have to isolate that object from other. Then identify all of the forces acting on that object. Then draw the arrow for each forces acting on it. So you have to write down the length of the arrow. Bigger the force, longer the length. Smaller the force, shorter the length. Then arrow determine the direction, in which direction that force is acting. Then you have to label all the forces, and you do not include the forces the object exert on other object and other things exerts on the object. You have to include only forces acting on it. That is very important thing. Okay, so then you have to look at here. In vertical, normal force and weight force are equal. So net force along vertical is 0, but there is a net force along horizontal because the tension force is greater than the friction force. Then you will have the net force here, or F net. Then object is start to accelerate. The box will accelerate here. That's how you have to deal with the net force situation. If there is a net force, then you have to go second law. We'll discuss about second law here. If there is a net force 0, then you have to go first law of motion. So that's how you need to deal with the net force. So net force concept is important, very, very important thing here. Okay, so I think you know now how to sketch the free body diagram, and then next lecture I will be connecting the concept of the net force and free body diagram. Now we are in a position to define first law of motion, second law of motion, Newton's third law of motion, and their implications in real life. So that's all for the net force. So you have to wait for another lecture for the Newton's laws.